So in this case, we are going to consider the condition of the inverse of a function, the inverse of a given function, where it can be greater than zero, where it can be less than zero, it can be greater than or equal to, it can be less than or equal to zero. So guys, this part, it is basically we just need to understand this condition of the original function to the inverse. Remember, this is a condition that happens when the graph of f of x is being reflected in the line y is equal to x. When it is reflected in the line y is equal to x. So what it simply means is that let's just take an exponential function so that we can understand here. If we have got an exponential function, which is having the y-intercept at 1, we can have that reflected in the line y is equal to x in this manner. We're going to have, remember, you swap these values. So the y is going to be our x at what? At 1. So this is what we're going to have. All right. And that is reflected along what we had before. It was the asymptote of x. And this time it is the y as our asymptote. So we're going to have our graph like this. All right. Which is a logarithmic graph that we are having. So if you check, if I am given f and I'm considering that f of x is greater than 0, f of x is less than 0, what is the consideration? Remember, we referred to this one, I think it was our first class on these typical questions. What matters is the x-axis to know that it is above the x-axis or below the x-axis. That is what matters. So if we have got this condition, it means the critical values mostly is going to be for the what? The x-intercepts. This will be our critical values. We're going to have the x-intercepts or the asymptotes when they are applicable. You consider the asymptote for x also to be judged according to the diagram. But the critical values will be what? The x-intercepts, remember. So this, guys, what we had on f of x is still the same when it is its inverse. When it is its inverse. Because the inverse is compared to what? To 0. So it is either it is above the x-axis or below. So meaning to say, whenever an inverse is to be asked like this, in this manner only, not a product to say it's going to be inverse to this, just an inverse like that. What matters here for our critical values, it will be what? The x-intercepts. So we must consider the x-intercepts when it is a quadratic function. For a logarithmic, it's just going to be an x-intercept. But remember, a logarithmic, or maybe when you consider this condition of a hyperbola, there are also asymptotes to be taken into consideration. So x-intercepts and also the asymptote, which is for the what? For the x value. This will be our critical values. From there, we can tell to say, is the graph above the x-axis or not? Is it above or not? When it is above, it is positive. When it is below, it is a negative. So this is the condition. All right. So greater than 0, we simply know that's a positive. When it is less than a 0, it's what? A negative. So this will be greater than what? Greater than 0. This will be what? Less than 0. So on a condition that the inverse is given, whatever that is given, you must consider above the what? Above the x-axis. So that is how you can simply answer these questions, guys. It's just direct as it is. So I'm not going to waste your time. Let us just consider some typical questions. We were given here, C given diagram below, gx is equal to k to the exponent of x. So there you were given also the point 236 is a point on what? On G, this and that. I'm worried about this question, which is for which values of x is what? The inverse of G less than or equal to 0. All right, this is our G, but they are referring to its inverse. All right, its inverse. So guys, for this part, I'm not going to be worried about what was our K, but K is greater than 0. And in that case, where in the y-axis where x is equal to 0, whatever that you put here, whatever value that is here, when raised to the exponent of 0 is going to give you a 1. So meaning to say, guys, the y-intercept where x is equal to 0 is going to give us what? A 1. This is on G. But we need its inverse. So the inverse was the graph that was drawn as a what? As a result of a reflection in the line y is equal to x, where we simply swap the values. So 1 in the y is going to be 1 in the x. So we're going to have something like that here. There's a 236. 236, you swap these, so it will be 36 versus 2. So there's a point 36 versus 2. This is 1, so 2 is maybe somewhere here. 2 for the y value, because this is 1 for the y, so maybe 2, it's so I'm just gonna approximate somewhere there. All right, somewhere there. All right, so let's say this is 36 versus 2. So it is awesome to note that before on gx, the x-axis was our asymptote. This time for the inverse, we change, so the y-axis becomes our asymptote. So the y-axis is an asymptote. So it's going to be something like this. All right, so that is our condition of the inverse of what? Of G. So this is the inverse of what? Of G, which, all right, this point is going to be 36.2. Do not worry about this, just for revision's sake. All right, so if we consider our inverse, where is it that our inverse in this case is what? Less than or equal to 0. Remember, what is important? The critical values. It is what? The x-intercept. And also the asymptote part. So we are limited in our y-axis to say that this graph of the inverse cannot reach the y-axis, cannot reach x is equal to 0. So that becomes a critical value to be considered. All right, it becomes a critical value to be considered. The x-intercept, it's a critical value. So we're going to have the critical value at what? At 1. That is for the x value. So you're going to have these values going up. All right, let me just use another one so that you can properly see what I'm trying to say. When I have this one, 1 like this, it's a critical value. So meaning to say x is equal to 0 for the y-axis, and for this one, x is equal to 1. Those are our critical values. So let us judge from those critical values. All right. If we check here on this side, we're not going to have any solution on the left side of 0. There is no solution because our graph cannot reach the y-axis. So let's consider from 0 to 1. From 0 to 1, our graph is below the x-axis. It is found below the x-axis because we are comparing, that is from what? The x-intercept. So it is below the x-axis. Anything below is what? Negative. So that is as negative between 0 and what? Between 0 and 1. All right. Then from 1, as we consider from 1, the graph is above the x-axis, meaning to say it is what? It is a positive above the x-axis. So here we need a condition where we have got a negative. that is below the x-axis. So below the x-axis, that is this region was going to be our answer between 0 and 1. Remember, it cannot exceed 0 there in terms, it cannot go beyond that 0 for x. So it is a limiting point. So meaning to say, therefore, our x is going to be greater than 0. X cannot be equal to 0. It's an asymptote. All right? So x must be greater than 0. But when we consider to 1, it is what? Less than 1. Is it going to be equal to? 1 is not an asymptote. It is an x-intercept, so that can work. So x can also be equal to 1 because we have got an equal to here. So we can also put it our equal to. But on the 0, we cannot say x is greater than or equal to 0. No, because of what? X cannot be equal to 0. That's part of what? Our asymptote at 0. X is equal to 0. This one is what? Is an asymptote. So x cannot be equal to that value. That is why we do not put the equal to there. All right. So mostly they'll ask you questions like this. If you check this one, it is similar again. For which value or values of what? X will the inverse of f be what? Less than or equal to 0. This is our f. And that was 3 to the exponent of x. When x is equal to 0 in the y-axis, it means we're going to have a 1. So y is equal to 1. At a, y is equal to 1. So it simply means the inverse of this graph, just like the previous one, when it is reflected in the line, y is equal to, in the line, y is equal to x like this. We are going to have the same thing, guys. This point is going to be here as what? As 1. So that was going to be like this. And in this case, we are limited again in the y-axis, where x is equal to 0 there as our asymptote. So that is a critical value. Whenever you have an asymptote, it's a critical value. X is equal to what? X is equal to 0. All right. And another critical value is what? The this x-intercept. As long the x-intercept is there, it becomes what? It becomes part of our critical values as long it is not part of the derivative. Do not confuse, guys, with the derivative where you work with turning points, the increase or decrease of a graph. This is the inverse. So the x-intercept is very, very important. So those are the critical values. So where do we have our inverse being less than or equal to 0 as a negative? So here there's no solution because our graph cannot exceed. This cannot go beyond this. So we are limited in this region, 0 to 1. In between 0 and 1, we can see that our graph is what? Below the x-axis. It is below. So in our case, it is a negative. All right. From 1 going up, we can see that the graph is found above the x-axis being what? A positive. As we need a condition when it is what? A negative. So this is the region that we want exactly from 0 to what? From 0 to 1. So therefore, our x is greater than 0. Remember, it cannot be equal to 0 because 0 is what? An asymptote. But less than what? But less than or equal to 1. All right, so this was just like a repetition, guys, of the previous one. All right, but that is it. So this is how you simply answer your questions. All right, let us just add another one just for the sake of revision. What about this region which is not satisfying this question? It is the one that satisfies the inverse of f when it is greater than or equal to 0. So when it is greater than or equal to 0, when it is positive, so you consider when it is above the x-axis from 1, the x-intercept, it is what? Above the x-axis. So therefore, x is greater than or equal to 1. 1 is not an asymptote, so x can be equal to 1. Just like that. So if it was for this one, that is how you're going to answer. But guys, answer the question, all right? You must answer the question. This is how these questions will be given as. They're just direct. Do revise as many questions. You'll see that it is just a repetition. they do repeat these conditions. So we are going to look into another aspect in our next class.